A complete look at your forecast comes up when I have weather on the threes at 7:33. Right now, it is time for more of Wise Guy Wednesday on the morning show. Matt Sullen joins us. Now, we got a question from Yankee Ridge Elementary School wanting to know why lasers are red. And it turns out that not all of them are.
Not all of them are.
It's just why.
It's just kind of easier to make a red laser, but you can make green ones, and I'll show that in just a second here. And the green ones are actually a lot brighter than the red ones are. They seem to be, but they're kind of expensive. So I just want to flip this one on again. If you could flip the lights off. There we go. So here what I have is a gas discharge tube that has some hydrogen in it. This is a different gas than I showed in the first segment. And what you see, the tube itself is in the center, but you should also see over to the sides some sort of brightish kind of lines.
Right.
And those lines are what's in front of here, what's causing that is the diffraction grating, which is like a prism, and it bends different colors by different amounts to the side. So the red is bent far out, the blue is not bent quite as far.
So this is breaking the light down into its component colors.
It's breaking
it. So it looks purple, but it's made of red and blue.
It's made of red and blue. And the interesting thing is, we can flip the lights back on. The interesting thing is that when you have atomic transitions, which is what happens when you excite a gas, which is like inside that little tube there, then you get very specific colors coming out only. And when you have an incandescent bulb, like the very bright bulbs that you tend to screw in and that burn out all the time, those are just white hot and they have all the colors blended in. Okay. And so the way a laser works is very similar to this. The way this works is you pop an atom into an excited state, it gets kind of excited, then it de-excites and it gives off a photon. It really does this. No, I'm just kidding. And so, and in a laser, what you want to do is you want to pop it into an excited state, which is metastable. It kind of stays there for a little while. And then what happens is, if you get one photon whizzing by an atom which is excited, it will cause the thing to de-excite. That's called stimulated emission, which is part of the word laser, as you pointed out to me. And so what you do is you get a little tube. I mean, this is much bigger than a regular laser tube, of course, and you have mirrors at each end, and you get light going back and forth in this, bouncing back and forth between the mirrors, and as the light bounces back and forth, it stimulates the emissions of more and more atoms until you get so much light bouncing in there that one of the mirrors causes, or is sort of not perfect, and the light leaks out one end.
Oh, okay.
And so you have sort of light sloshing back and forth in here. It's a little bit like when you're in a bathtub, and you slosh back and forth. Have you ever done that? You can get a very large amplification of the wave going in the bathtub until your mom goes, "Stop that!" Right? And so here you have this photon sloshing back and forth until you get a very large amplification and the light leaks out the end. And you can do that with these red lasers very easily, and with these green ones.
The green one is much brighter.
The green one is way cool.
Yeah.
It costs a little bit more. It's a little fancier. And these
professional model.
That's right. Yeah. That's right.
I have a quick question about laser. How is the beam focus maintained so tightly over distance? Like a flashlight, obviously, you turn it on and you got a big circle on the other side of the room, but a laser stays small for a long way.
It has to do with the size of the actual aperture where the light comes out, the size of the little amplification cavity, and the photons are all stimulated in the same direction, so they come out in the same direction. So they just stay together. They don't come out in all directions. They come out in exactly the same direction. Okay. So you can actually shine a spot on the moon.
All right. Thank you. Matt Sullen, our wise guy, explaining to us how and why lasers work and why some are red and some are green. If you've got a question for the wise guy, you can email it to us.
And next week we're going to talk about the transit of Venus. Very, very exciting.
Yes. This is like 130 years since that happened. Anyway, questions for Matt's morning show at wcia.com, or you can call our feedback line, or you can email him directly at thewiseguy.net.
That's a lot of information to ingest.